the SPSS lab. That's what we'll be working on in this video from the module where we're covering chapter 8. That's where you will find this lab right here. But in order to do this lab, you are going to need SPSS. So if you scroll up, there is a link at the top of the home page under resources where you can download a free version of SPSS. So make sure that you go ahead and do that before you continue on with the lab. Then what I'm going to need you to do is come on down to the lab here on Canvas. Click on it. And then what we're going to start with is this file labeled descriptives.docx. So if you could click on that file and open it up, it should look like this. And so once you have that file up, you'll need to also open that SPSS that you have downloaded. So you'll just go ahead and click on that and wait for it to open. Okay, so then once it opens, you could, if you had a file to upload, and you can play around with SPSS if you want and upload like your pilot test data and your pre-test data and practice some of the stuff that you're going to learn in lab today. Sometimes transferring that data from Google Forms into SPSS is difficult because SPSS doesn't always like words or special characters, and so generally we have to clean the data before we can move it into SPSS. But since we're just going to be getting rid of the pilot test and pre-test data anyways, if you want to just upload it and play around in SPSS, you could do that. But at any rate, today we don't need this box here because we are going to be putting in our own data rather than uploading a data file. So this is SPSS. I'm going to give you just a little bit of a lay of the land here on SPSS. So there are two views. If you look at the bottom of the screen, you can see the two tabs. On the left, we have the data view, and that's what we're looking at here. This is where all the data will appear, all of the numbers. And then on the right, we have the variable view, and this is where you tell the program what your variable names are. You can tell them, you could tell SPSS what type of data it is, if it's interval, ordinal, nominal. You can tell it how many decimals you want it to display, and you can give it like little nicknames and stuff under the label. So we'll be learning all of that today. So anyways, you put the variables in, and then you toggle back down here to that left tab that says data view, and then the variables will appear up here, and you can start entering your data. So this first thing that we're going to do in this lab is to get our descriptives. And descriptives are mostly statistical analyses of the participants. So just kind of gathering some descriptive data from your demographics and places like that. So we are going to go ahead and get out our worksheet. This one here, the Getting Familiar with SPSS. And this one in particular is for our descriptives. So it says a psychologist administered a self-esteem inventory to 22 students in a statistics class and obtained the following scores. And here are those scores. It says enter the self-esteem data in SPSS. So I can come over here. Oops, nope, not there. I can go to SPSS, wherever that went. I think it's here. Okay. And the worksheet tells me that it wants me to enter the self-esteem data in SPSS and name the variable and give it a label. So I'm actually going to do the naming of the variable first. So this is self-esteem. And sometimes SPSS can be really picky about characters and spacing and stuff. So I just never leave any spaces or do any special characters. And then in my label, I'm just going to label it SE for self-esteem. Okay, and then I'm going to come back to my data view, and here it is here, my self-esteem variable. And then the worksheet asks me to plug in the data there for the 22 students. So I'm going to go ahead and do that. If you have a keypad on a keyboard, that works best. On my laptop, I don't have that, so I'm just typing it in up here at the top. So I just go cell by cell and I enter all the data. So you can join me in doing that. Hopefully I don't mess up here. 23, 20, another 23, 24. So I'll know I did it right, or I'll be likely to have done it right if I end up with 22 cells here. 17, 28, 19, 21, 20, 28, and 25. Okay, awesome. So I ended up with 22 numbers there, and I had gotten this data from 22 students. So that all works out nicely. So then the next step is to go ahead and run some basic descriptives so that we can fill out the rest of this worksheet, get frequency, get percentages, and then get some graphs that we'll need. So what we're going to do here now that we have our data plugged in is we are going to go to Analyze, Descriptives, and then we're going to go to Frequencies. So go ahead and make your screen look like mine and do Analyze, Descriptives, Frequencies. Click on that. And then what you're going to want to do is take that variable and pull it over. And there's a lot of ways to do that. You could double click on it, or you could just click on that arrow and pull it over to the variable. So this lets SPSS know which variable we are going to be doing statistics on. So after I do that, then what I'm going to want to do is click Charts. And I would like to get a histogram. And I'm going to click Show Normal Curve on the histogram so I could see how my curve and my data compares to a mesokurtic shape or the normal curve. And then I'm going to click Continue on that. And I think we're going to be good to go. Okay, so then we can just click OK. And what's going to happen from there is an output is going to pop up. This is our output here. This is where your statistics will appear. It's going to be a completely separate window. And so when you get your output, you don't want to delete it. You want to just keep adding to it. So you want to save it. We're going to save it as, we'll do Descriptives. Just put Descriptives lab. Okay, and I'm going to save it as a .spv, and I'm going to save that to my desktop. Okay. All right, so I have that saved, and now I can take a look at my data. It says I had 22 participants. Here it shows the frequency of scores. So one person had a 15, one person had a 16. Looks like 3 people out of 20, 2 people out of 21, so on and so forth. And then you have the percentage of people that are getting those scores. And so we're going to look at the percentages here. So 4.5% of people put a 15, 13.6 put a 20, so on and so forth. So that's how I would read these stats. And then I'm going to scroll down here to my beautiful histogram. And I could see how my data compares to the normal curve. Looks like it's skewed to the right just a little bit, but pretty normal for the most part. I got the most data occurring in the middle, and then it levels off pretty much here at the sides. Okay, so that is a histogram and the descriptive stats. So you'll be needing this data for your methods section. You'll be needing to report percentages for your demographics. And so this is where you will get those percentages once you plug in the data for your demographics. Okay, and I'm going to need this histogram on my worksheet here. So I'm just going to do a screenshot of it. You could look up how to do a screenshot using the type of computer that you have, but that's how I do it on mine. And then what I would do is I would take that screenshot and I would put it right here. And you'll need to have histograms for some of your appendices as well. So that's how you will get them for your appendices. You could just do a nice screenshot. I right-clicked on it, and I'm going to put the wrap the text through so that I can move this wherever I want. Somehow I got 2 on there. Okay, just formatting this. Okay, and then the worksheet wants me to put how many students scored a 23. So let me come back to my output. And it says that there were 4 students that reported a 23. So I'm going to come back to my worksheet and add 4 there. And then the percentage of students who scored a 20. Let's go to a score of 20, and it says the percent is 13.6% for that. Minimize my worksheet, and I will plug in 13.6% there. Okay, and then for the last part of this application, I need to create a frequency polygon. So what I'm going to do is go back to SPSS to my data view, and I'm going to go up to graphs, and then I'm going to click on chart builder, and I'm going to put OK. All right, so then actually what I want to do, even though I am building what's called a frequency polygon, I'm going to come down here to histogram, and then I am going to just place my mouse over the pictures. And I'm going to find the one that says frequency polygon. On mine, it's the 3rd from the right. And then I'm going to drag that to the box here. And then what I'm going to do is drag the variable to the x-axis. So I'm going to grab that self-esteem variable, put it there. And then now I have a frequency polygon. I'm going to click OK on that, and it'll show up here on my output. And then I'm going to do a screenshot of my frequency polygon and add that to my worksheet. Save my output. Okay, and then I'm going to add that to my worksheet. Here's my worksheet. Okay. Saved it on my desktop. I'm going to wrap that text through so I could put it wherever I want. Just right click on it to get that menu to pop up. Drag it back up here. Okay, and so I have now completed SPSS application 1. If you would like to, you could practice number 2 on your own. It's just doing the same skills that we just learned. So go ahead and practice that if you would like. Again, you're going to need these descriptives for your method section, particularly in the participants subsection where you need to report the percentages of your demographics. Completed SPSS application number 1, and hopefully you've had a chance to try number 2 on your own. And now we're going to do SPSS application number 3 from this descriptives worksheet. And you're going to be learning how to calculate measures of central tendency and variance, and you will need this information for your method section as well as your results section. So you'll be needing this information throughout the course. So here is how you get these values down here. So it says a psychologist administered a stress inventory to 25 students at a freshman orientation session and obtained the following scores. Here are the scores. Enter this data in SPSS, name the variable stress, and give it a label. So, let me minimize this. I am going to give it a label that matches my key if this were my actual survey data. So if I was doing a variable named self-esteem on my key, I would probably have a label like SE. So those are the labels that we're putting here. But for this one, it said to name the variable stress, and then the label that I will give it, I'm just going to give it an S. Maybe I'll do a STR for stress. Okay, you can label it whatever you want. So then I have that there, and I'm going to hit enter and go to the data view. And now here is my stress variable. So because I left my self-esteem variable in there, it's assuming that I have 22 participants, and that's why there are dots all the way through cells 1 through 22. But we can change that if we need to. Okay, because here we have 25 students, so we'll just be adding to that. All right, so we're going to enter in the data from the worksheet, and if I enter it in correctly, at least if I get everybody, then I should have 25 numbers at the end of this, because I have 25 participants. So we'll see how I do. I like to have someone else read me the numbers while I put them in normally. 32, 44, 15, 36, 37, 22, 38, 48, 31, 42, 34, 26, 17, 38, 49, and 12. Okay, so now I have all the data entered in, and let me see what statistics the worksheet wants from us. It wants mode, median, variance, mean, and standard deviation. Okay, so to get those values, what we need to do is go to Analyze, Descriptive Stats, Frequencies, and then we're going to move that self-esteem variable out of here because we're not interested in that right now. We're interested in getting the statistics on our stress variable. So I'm going to move that into the variables box. This is telling the program which variable we're working on. And then what we're going to click on is statistics. And we're going to check mark what we like or would like. We would like mean, median, and mode. And we would also like standard deviation and variance. So after I tell the program what I want, I go ahead and click continue, and then I click OK, and then up pops my data for STR or stress. Here I can see that the mean is 33.68. The mode is 38, the median is 36. I have a standard deviation of 11.42. I would round that to 11.43. And then my variance is 130.643. And here's all the frequencies again and percent. And it just did a histogram because it was that command was probably left in there from our self-esteem variable. So it looks good. I had 25 numbers as expected, an N of 25. All right, so let's go back to that worksheet and going to kind of do a split screen here. Okay, so it wants the mode. I see the mode here is 38. It wants the median. I see the median here is 36. The worksheet wants the variance. So I see the variance is 130 point. I'm used to rounding to the second digit after the decimal, so that is what I do. Oh, I put that in the wrong spot, didn't I? Let me get that out of there. Put it in the variance. Okay, and then the mean, 33.68. And the standard deviation is 11.4. We're going to round that last digit up to a 3. Okay, and that is how you get central measures of central tendency statistics and measures of variance or measures of variability statistics. Go ahead and do number 4 on your own if you would like to give it a shot. Again, you will be needing to do these calculations on your actual data once we have it. The point of this lab is just to introduce you to SPSS and these calculations and give you a tutorial so you know how to do it when the time comes. Okay, so for the second half of this lab, we're going to be doing a Pearson R statistical analysis. So in order to do that, we're going to need to go back to our Canvas course, and then we're going to need to go back to the SPSS lab and click on it, and then get that Pearson R.doc. I'm going to show you how to do a Pearson R in SPSS. So if you have done this statistical analysis, then this is what you will be reporting in your results section of your paper to determine if you have supported your hypothesis or not. So this lab will teach you how to do that, as well as how to write the statistic in APA format, because you will have to do that on your in the results section of your APA paper as well. Okay, so it says, suppose that an educational researcher knows the average class size and average achievement test scores from 5 elementary schools in a particular small school district. The scores are as follows. So we have class size and test scores. So again, when we're doing a correlational study, we have our two variables and we're just testing a hypothesis of association, which is a hypothesis that looks to see if our two variables are related in any way, if they're correlated. In this case, as class size increases, what happens to test scores? Do they increase or decrease? And that is what a Pearson R is able to tell us. So a couple things we can fill out on this worksheet before we start entering our data into SPSS is the type of statistical test we're doing to analyze this data is a Pearson R. And so when we are writing our statistics, there we go. When we're writing our statistics, all statistical symbols need to be italicized. So that R is a statistical symbol, so I went ahead and italicized that. And that is also going to be true in your papers. All statistical symbols must be italicized. If there's a number associated with the statistical symbol, that is not italicized, but the actual symbol itself would be. Okay, so if we were to state this research hypothesis, we could say that for our HO, which is the null hypothesis, so the hypothesis of nothing, essentially, we could say there is no association between class size and test scores. So obviously we hope to reject that. And when we reject that, it makes our alternate hypothesis, which is sometimes labeled or symbolized as H1, sometimes it's symbolized as HA. Either way, it's our actual hypothesis that we're never able to talk about. And so when we reject HO, by default, we accept H1, but we never say that. We just say we reject or accept HO. Okay, so for our alternate hypothesis, which is our actual hypothesis, we would say there is an association, or you could use the word correlation, relationship. Any of those synonyms would work between class size and test scores. Okay, so that's how you would write the hypotheses. And then to complete the rest of this worksheet, we're going to have to do our statistical analysis. So to do that, I'm going to come over here to SPSS, and I'm going to go, let me try to do a split screen. There we go. Okay, I'm going to go to the variable view. And in the variable view, I am going to write the name class size. Keep them together like that. And then for my label, I'll just label it CS for class size. And then the other variable is test score. Test score, and I'm going to label that TS. Okay, if I want to have my variable view only have whole numbers, so no digits after the decimal, then I would change that to 0 digits after the decimal. You can do that if you'd like. You don't have to. It's just a preference thing, how you like to look at your data visually. Okay, so now we're going to go in and enter the numbers from the worksheet in their corresponding columns. So I have class size of 25. I'm just hitting enter after I put in each number, and it just bumps me down to the next cell. Okay, so it says I have 5 schools, so I should have 5 numbers, and I do. And then I'm going to do the test scores in their respective column, 50, 82, and 90. Okay, cool. All right, so now I have the data entered. So what I need to do is run my Pearson R, and I also need to get a visual representation of that data. I'm going to do that in the form of a scatter plot, or sometimes it's referred to as a scatter diagram. So we're going to be doing both of those things. In your final paper, the scatter plot would be appendicized and referenced in your results section. So you will be needing to do this for your final papers. Okay, so to run the Pearson R, you're going to go to Analyze, and then you're going to go to Regression, and then you're going to go to Linear. Click on that. And then you're going to move test score into the DV and class size into the IV. You can kind of do your best guess on that as to what you think seems more like the IV and seems more like the DV. Although, because in correlation we can't infer causation, we don't have like a true IV and DV in the way we would have an experiment. So it generally doesn't really matter which one you put where. But take your best stab at guessing what's the IV and DV, just to make it more understandable to the reader. Okay, so after you get those values in their proper locations, you're going to go to Statistics. And the statistics that you need to collect here are going to be the model fit, the R-squared change, and go ahead and click Descriptives too. Okay. And then we're going to go ahead and click Continue and click OK. And then it will pop up on your output. This output, you are going to need information for writing your result in APA format, or writing your statistic in APA format. And we're going to do that on this worksheet right here. So I'll show you how to write it in the correct format and where to pull the data you're going to need from your output. So the first thing that you have to write is R, and that needs to be italicized because it is a statistical symbol. And then after the R, you need, actually right next to it, you need parentheses, like so. And inside those parentheses, you're going to be putting your degrees of freedom. The degrees of freedom that you're going to use is going to be under that ANOVA section, and it's your degrees of freedom residual. So in this case, it is 3. So I'm going to go back to my worksheet here and write 3. I would like to get this parenthesis a little closer. There we go. Okay. So after I write that, I'm going to put an equal sign. And at this point, I'm just going to copy and paste to the 0.01 so that I don't have to rewrite that with all its special formatting and everything. The next part is the actual correlation coefficient itself, which is located in this coefficients table here. And under the standardized coefficients beta is where you will find your test statistic, or in this case, your R value, your correlation coefficient. And it is negative 0.90. So I'm going to put negative 0.90 there. And then I put a comma after that, and I would need to indicate if we have significance or not. Do I have enough significance to reject HO? And so what I look for is that this value right here, the one for the CS variable, the second row, that significance needs to be lower than 0.05. So I'm just going to kind of disregard. I guess I could round this up to 0.04 if I wanted to, but if we're just looking at the 2 digits after the decimal, those 2 digits need to be less than 0.05 in order for us to reject HO. If they are not less than 0.05, we would have to write NS on our worksheet, and that would look like this, NS, and then we would italicize the NS because that's a statistical symbol. But in this case, we actually do have significance because 0.03 is less than 0.05. If you think of it in terms of money, that could be helpful sometimes. So if you think of having 3 cents, that's less than having 5 cents, and that's what we want. We want to have as close to 0 here as possible, and the closer we are to 0, the more confident we are in our results. So at any rate, we have negative 0.90, and that's significant at 0.03, which is less than 0.05, but not less than 0.01. So the way we would write that is P, and again, that needs to be italicized because it's a statistical symbol. And then we're going to click right next to it. Okay, and we're going to do the less than symbol, and then we're going to write 0.05. And so then we'll actually do the same thing here. I guess I could have copied and pasted this at the end. I don't know why I felt compelled to do it right there at the top. Let me just save myself the headache. Oh, you know what? No, actually, because that's not significant. So I just need this part. Okay. So, since it is less than 0.05 but not less than 0.01, at the 0.01 level, we would have to say NS for not significant. And like I said, we would italicize that. Get rid of this. It looks nicer. Okay. And that's how we would write our statistic in APA format. So on the actual results section of your paper, you don't need to write it twice. That's just for learning purposes for the worksheet. But you would write your sentence one time, and it would either say P less than 0.05, P less than 0.01, or NS. Okay. So in this case, what does this test statistic tell us about the data? Since the correlation coefficient is negative, it tells us that the direction of the relationship is opposite. So as one variable increases, the other variable decreases. So I could write that down here as, let's see, the variables are class size and test scores. So as class size increases, test scores decrease, and vice versa. Okay, also this is a pretty strong correlation here. A 0.90 is pretty high, so that's, even though it's negative, it's still high. Anything close to 1 or -1 is a strong correlation coefficient. So we have a strong correlation coefficient here and significance, so we're able to reject HO, and we found that as class size increases, test scores decrease, and vice versa. So the last step of this worksheet is to get our scatter plot. On SPSS, you're going to go to Graphs, Chart Builder, and then you want to, let me reset this. Okay. You want to, so yours should look like this when you access the chart builder, and then you're going to come down to Scatter Dot on the left options menu here, click Scatter Dot, and then you're going to want to go to the second one that says Simple Scatter with Fit Line, and you could just double click it, or you can drag it to the box. And then what we're going to do is put our variables here, so I'm just going to drag them to the axis I want them on. And then once you have your variables in their proper locations, just notice that this display here is just example data. It's not how your chart is going to look, so don't let that throw you off. But after you have everything placed in your chart where you want it, then you click OK. And your output will pop up, and it should look something like this for this one. So I'm going to just take a screenshot of that because I'm going to need this on my final paper in the figure section. Okay, so then after I have that screenshot, I'm just going to minimize this. I think I'm done with SPSS for now. Okay, and then I'm going to take that screenshot and I'm going to put it on my worksheet. Again, I'm going to wrap that text through so I can put it wherever I want. And I'm going to make it a little smaller. There we go. Okay, so just to answer the questions on this worksheet, the shape of this scatter plot looks linear. It's not curvilinear. It's not increasing, leveling off, and decreasing. All of the dots seem to be going in a linear pattern. The direction is negative when the fit line goes this way. It's a negative correlation, and that matches what our test value was, a negative 0.90. So that means that as one variable increases, another variable decreases, and vice versa. And then the last thing we check for is the assumption of homoscedasticity. We want to know if we met that. And so if we met that, we should have approximately an equal number of dots above and below this regression line or this fit line. And so here it looks like I have this one above, one below, maybe one more below over here. We do have an odd number of data points with 5, so it's okay that one's above and 2 are below. I would say that overall we met that assumption of homoscedasticity. And that is how you do a scatter plot.